Hi, I'm Brian Malow, coming to you live from the 72nd Lindau and Nobel Laureate meeting here in beautiful Lindau, Germany. This week we have assembled about 40 Nobel laureates and 600 young scientists from 89 countries. I'm talking to one of them who, we previously met virtually.
That's right.
When, because of the pandemic, the meeting had to be virtual. We have an unexpected bit of traffic in an area where you wouldn't think cars would be. But expect the unexpected.
Yeah.
So Lorenz Adlung is a systems biologist.
That's right.
And you're at the University Medical Center Hamburg?
That's correct.
I read it right off. Of course it's correct. I read it right off your name tag. But what is a systems biologist?
Well, a systems biologist is actually two scientists in one, because on the one side you have this very theoretical and conceptual view on the world. You know, if I see a human being, I don't see a human being in the first place. I see like a biological machine that is walking around.
Yeah.
But then I'm also like a biologist who's just fascinated with life itself, and I would like to, decompose it into all its individual units, cells, molecules, and understand really how this is working. And I mean, yeah.
Well, what was your sort of academic training to get to that point?
Oh, well, I went to boarding school, which is specialized in math and science, so I got it right from the beginning. However, I studied biology, classical biology, in my bachelor's. But aside, I already took like courses in mathematics and computer science, and then since my master's, I took classes in really what's called systems biology, and then also my PhD was on systems biology, and my postdoc, and now also my own group.
So you're past the postdoc. Yeah. What are you? How would you say? What level? What kind of scientist you are?
I'm now an independent researcher. I have my own group. I'm an independent junior group leader. I mean, I'm 34, but still in science, this is still considered junior.
Yeah.
So yeah, I feel still quite young in a sense. And I really made it through all these steps from a PhD to a postdoc, now to an independent junior group leader, and it's just a so exciting journey. I mean.
So you're a group leader, and you said the systems biology.
Yeah.
But what do you actually do? What kind of problems are you working on now?
Well, I have this very conceptual interest. So like having a systems perspective on biological entities, biological processes, and so it's widely applicable. However, my main focus is on my favorite organ, and my favorite organ is the adipose tissue, or to be a bit more colloquial, fat.
Why is adipose tissue or fat your favorite organ?
Well,
you don't hear that very often.
Yeah, it's true. I mean,
for a lot of people that aren't scientists, it's their least favorite organ.
Well, I must say it's fascinating in the sense that its structure doesn't seem to be very sophisticated, right? If you compare it to other organs, for instance, the liver or the brain. I mean, the brain looks very sophisticated, right, in terms of structure. The fat is not. However, if we look closely enough and we really scientifically scrutinize it and tear it apart, we see there's a lot of things going on in the tissue, and there's a lot of structural diversity that we see in the tissue, and we have really no clue what's the consequences for us walking around with all these fat depots, for the better or the worse. I mean, fat is not always bad. That's also something that we learned.
We do need some, right?
Yeah. And also when I talk about this, actually I get a lot of replies from people all around the globe, or I mean, no matter, depends on where I talk about this, that actually come to me and say, I have a lot of adipose tissue. Don't you need biopsies? Don't you need material to experiment
Take
with?
some.
Yeah. So this is quite. I mean, I feel quite. I'm grateful for this kind of interactions that I have with the general public in this respect.
Can you give me an example of what's something interesting that adipose tissue does?
Yeah, I told you that there's a lot of stigmatization that comes with excessive body fat, which in part is true, but at its core it's not really scientific. This kind of stigmatizing and prejudice, because we actually found that in the fat tissue there are immune cells which can be beneficial for our health. So there might be people that have a lot of prominent body fat depots. However, there are some immune cells in their fat tissue that actually protect them from developed metabolic diseases, which is very counterintuitive, because you would think if you have a lot of fat mass, then also you have a lot of high blood sugar, you have a lot of high cholesterol in your blood, but this is not necessarily true. So if we look into the data, and meanwhile there's even epidemiological data, This is true for a certain fraction of people, certainly, but it's certainly not true for all of those people, and therefore, as I said, all these stigmas that come with adipose tissue, they are not really scientifically justified, and I want to debunk these myths about fat.
That's excellent. And I know that you have taken part over the years in many different types of unusual science communication.
That's true. I mean, science communication is close to my heart. I mean, there's also a fat tissue that surrounds the heart, so it all comes together. But I think science communication is important for various reasons, and one of these being that we tell people what we do research about, so they basically the barrier is lowered and science gets more accessible, because then again people approach me, they even want to donate some material for me to do research, which is fantastic. And there's so many different ways to do science communication. Sometimes we are under the impression that now with social media everyone must do science communication and it seems like a burden, but matter of fact, science communication itself is so versatile. Everyone can find their own niche to do something science communication, and it's fun, it's so rewarding. Just to give you an example, I started with science communication with Science Slam. I'm actually, if talking to strangers is not really, I don't feel comfortable, I'm rather an introvert, but when I'm on stage, I go berserk. So I love these entertaining performances. I share my enthusiasm with science that I hope comes across, right? And on stage this works very well. And then for instance, if I go to scientific meetings, of course, and you give talks there, you're also on stage, and it's also rewarding. However, I've been to conferences. I think I gave talks that were not necessarily bad, but then the best you can hope for is that you get like modest kind of applause and maybe one or two interesting questions. Now, if I do Science Slam on stage and I do even like rap music about my science and stuff, people start, bouncing and cheering and applauding like wildly, and then they approach me afterwards and say, Lawrence, this was super interesting. I want to know more about fat. Tell me more about fat. And this reward is on a completely different level in a sense. So science communication is fun and is rewarding.
What is a Science Slam?
A Science Slam is like a short, entertaining presentation of scientific results. Some people strengthen the entertaining aspect a little more. Some strengthen the aspect a little more that it must be informative. However, I think the point is just that you share your emotions, because human beings are empathic animals after all. So if somebody shows emotion, then people are more likely to sort of connect. And there's even scientific data on this, that if we share emotions, then people feel more connected and they take whatever message you want to convey, they take it more seriously, and the chances are more likely that they sort of will identify themselves with this question or ask further questions. Anyways, and these emotions, interestingly, they do not only work with positive emotions. So if I share enthusiasm, the chances are more likely that you also feel enthusiasm, because you have all these neurons that sort of mimic what you are seeing in a sense, and my emotions. But this connection also works with negative emotion, because one aspect we don't talk about so often is that science, I feel very privileged to be in science, I'm very grateful, but science also comes with a lot of failures. Like we do experiments, and in most of the cases they do not work, which is not our fault, it's just the way science is. It's a trial and error process, which can be very frustrating. And if we share this frustration with the public, they may have never done an experiment in the lab, but they know what it feels like to fail, right? And then suddenly they also make a connection and say, this guy is very sympathetic in a way. I feel sympathy for him because he seems to fail a lot, and this poor scientist, and suddenly they connect, and we step out of this ivory tower by just, bonding with people on an emotional level, and then we are much more likely to bring our scientific messages across.
That's excellent. I understand that you also have recorded a rap album.
Yeah, and actually this came directly from science communication, because in 2020, I believe, there was an open call for science communication in times of the corona pandemic, COVID-19 pandemic. And I thought, why not using rap music to make scientific findings accessible to people who are not going to Science Slams, for instance, because when I looked into the crowd there, I saw usually people at least with some more highly like an educational background to some extent. But I myself, for instance, I'm from a non-academic background, and these school kids from non-academic backgrounds, maybe also from migrant families, rap music is quite popular. It's sort of in their generation. So I thought, maybe I can use rap music as some sort of vector or vehicle to transfer messages about my research to them. So I applied for this grant and I got the money, so I produced like a rap album that is entitled COVID, okay? And it's 5 songs, and the starting letter for every one of the 5 song titles is like COVID.
Are they all COVID themed or a little broader than that?
They are all scientifically related. So one is about life in academia, then there's something about how we find our path, like when choosing a scientific project. So it's more like a reflection on this. And I also took the degree of freedom to, so I'm not rapping under my real name, but I chosen an artist name to also create some sort of distance. So I can be in a bit different position and can be very critical with the scientific system, where I still need, people to support me, and I don't want to,
So the album is called COVID, and who's the artist?
The artist is called Doku, which is D-O, and then there's a double point, and then K-U. And I don't want to spoil how I came up with this name, but people may figure it out eventually.
Do you want to give a small sample of a verse?
I think so the album is in German. However, since one of the key focuses on this meeting here was also diversity, the song about academia, with very critical lyrics on the academic system, revolves around this idea, what I experienced, that the academic system is very sexist in a sense. So women are have systematic disadvantages, and I think one of the reasons is actually that all these committees who decide about our success in science are mostly male panels, and then consciously or subconsciously, people again to whom we can relate more, we are more likely to think of them in favorable. So if I'm a panelist and I have certain people to judge, maybe I will just judge the male people more likely because I can more identify with them, right? So one line I have in this rap is basically is as simple as that: men support men, right? And this is what happens, again, subconsciously or consciously, but this is something we have to overcome by, various means. I think there's not this simple solution. That's why it needs more than a rap album or just one kind of dedicated meeting for this, but we need to sort of start thinking about this, like all different key players in the system, but also we as a scientific community as a whole. So yeah, men support men is definitely one of the problems.
Okay, excellent. Now, I know you want to get to a lecture, but here we are at the meeting. Tell me a couple of highlights you've had.
It's overwhelming. So usually, I have no difficulties when I'm in bed to fall asleep. Like I at most manage to read 1 or 2 pages and then I fall asleep like on the book. Here, my hotel is a bit distant, like it takes me a 50-minute walk, so I have a bit of time to reflect each and every night already. But then I arrive in my apartment, I sit in bed, and I'm still sitting there for 2 hours, 3 hours easily, and I'm just reflecting on all the input I got, which is so impressive. If I had to name one thing that I found super impressive among all the very impressive things, then it was the open exchange with Avram Hershko. So he is a Nobel Laureate. He discovered the ubiquitin system and basically how proteins in our cells get recycled or degraded. And he is, I looked it up yesterday, I believe he is 86 years old. And he told us that one motivation for him is he goes to the lab every day and he does experiments every day on the bench himself. He's a biochemist, so he stands on the bench every single day of his life and does experiments. And why does he do it? Because it's fun and he loves it. And sharing this enthusiasm and this true love for science and for good scientific practice as well, because he strengthens that it's not just doing the experiment, but also having the right controls, a positive control and a negative control is essential to be a good scientist. And this, I could relate to this so much. And then again, we have this, also on an emotional level, we have the connection and we inspire people. And this is exactly also the motto, right, of this meeting, that we educate, we inspire, and we connect. And I think this sums it up amazingly.
Excellent. Well, thanks for taking the time to talk to me.
My pleasure.
And enjoy the rest of the meeting.
Thanks a
and
lot.
Lorenz is just one of the 600 young scientists here this year at the 72nd Annual Lindau Nobel Laureate meeting. And we'll be hearing from more of them later this week.